Precalculus second mid 9 weeks common assessment 2019-2020. We had our assessment in Precalculus here this week. 22 problems, and we're going to these in this video lesson. And the first I want to look at is problem 1. Which following divisions will produce a remainder of 13 over x minus 1? So we have all these following expressions divided by the expression x minus 1. There are different ways to do this. One of which is to use the remainder theorem. If you use the remainder theorem, if we find the 0, so let's take x minus 1 equals 0, and we add 1 to both sides of this equation, we're going to get x is equal to 1. So if we plug in 1, so if we put f of 1 for choice A, we get 1 cubed plus 2 times 1 squared minus 3 times 1 plus 1. We're going to get 1 plus 2 minus 3. That's going to be 0 plus 1 plus 1. And that's going to be the remainder of 1 over x minus 1. So that is not right. Another thing you can do is do synthetic division. I'm going to try synthetic division with choice G. And if you set up a synthetic division bracket like this, and we put our 0 outside, which is 1, and the coefficients inside, 1x to the 4th, 3x cubed, we don't have any x squared, so we put 0 for the next number, and then 5, and finally negative 10. And if we go through all this and get 13, we'll know that's right. So let's bring down our 1. 1 times 1 is 1. 3 plus 1 is 4. 4 times 1 is 4. 0 plus 4 is 4. 1 times 4 is 4. 5 plus 4 is 9. 1 times 9 is 9. Negative 10 plus 9 is negative 1. So that is a remainder of negative 1. Not a solution. Okay, that's your choice C. Again, I'm going to try f of 1. Plug in 1. You get 2 times 1 cubed minus 5 times 1 plus 16. That's going to be equal to 2 minus 5 plus 16, which equals 13. And if we use our synthetic division, we'll get the same thing, 13. So we put 1 out here. Then we have 2x cubed, 0x squared, negative 5x, and 16. So we get 2x squared. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 5 plus 4 is negative 1. 1 times negative 1. No, somehow doesn't look right. Does it? One, 2, 1 times 2, definitely, that's 2, that's not a mistake. 1 times 2 is 2, negative 5 plus 2 is negative 3. That's negative 3 right there. And then 1 times negative 3 is negative 3. So we get 13. I wasn't getting 13, that would be a mistake. Yeah, so C is our correct answer. Next, for the following division problem, what would be the proper synthetic division setup? Again, if we have our denominator x minus 3, set that equal to 0. So we're going to have a 0 of x is equal to 3. So 3 will go on the outside. So these negative 3 ones will go away. And we have 1x squared. We don't have any 1x cubed. That's 0x squared, 2, 6, 3 on the outside. That is answer choice. Next, the partic function hx equals 4. Power plus 5x cubed minus 8x squared minus 48x has 3 and zeros, which allows us to do 2. If we go to our calculator, I have my TI-84 CE calculator. I have the function pre-entered. And if we graph this function, just press graph, we have a 0 apparently with x equals negative 4, and x equals 0, and x equals 3. And we have the graph that touches but does not cross. That is going to be an even number multiplicity. And that's going to be the 0 of negative 4. So x equals negative 4 is going to be our answer to this question. But look at the graph. Which following functions is the inverse function of h of x equals e to the x power? And basically, it's your understanding. If you understand that you have a function e to the x, its inverse function is going to be ln x. And to graph these, very, very easy to do. Go to our calculator, we put in e to the x here, e to the power of x, and then put here ln x, which could be this natural logarithm ln x, and that's what we get. So a red is going to be e to the x, the magenta is going to be ln x. So these two functions, the red one and the magenta one, are inverse of each other, and our correct answer is therefore C. Next, which following polynomial functions has an even degree and is negative? Well, for even degree, we look at the highest exponentiated term out there. And we have to have an even degree and cross out the odd degree ones, these two here, and is negative. Well, in B, in the part, choice A, we have negative x to the 4th power. That's going to be our answer. Next 6, hoarding rationals, and what will be the list of potential rationals of the function. Basically, what you're looking for is plus or minus factors of last term over coefficients of factors of first term. Factors of coefficients, I got backwards. Let me rewrite that more properly. Over factors of coefficient of first term. So what we have is plus or minus the factors of 14. So that's going to be factors of 1, 2, 7, and 14. And over the factors of coefficient of first term, well, we have x squared, so that's going to be 1x squared, so that's going to be 1. So what we're going to have here is plus or minus 1, which is 1 over 1, plus or minus 2, plus or minus 7, and finally plus or minus 14. Yes, our answer is A. Next problem. Which following rational functions in the answer choices has the following formula? So you can kind of set your denominator equal to 0. Like you want to try answer choice B. If you set x plus 20x plus 3 equals 0, we got x is equal to 0. X plus 3 is equal to 0. And solving, we have x is equal to -3. And really you're looking for where it's not equal to. It's where your discontinuity is 5. X cannot equal -3, but I frequently think this domain is going to be 3. This is not right. If we try answer choice A, we get x cannot equal 0, and using the zero factor property, x minus 3 cannot equal 0. So x cannot equal 3, and x cannot equal 0. That's consistent with what the means up here. And then what this looks like in a calculator. X over x, that's probably x minus 3. So we graph this, and it looks like, well, I'm going to get rid of this blue equation here since we don't need it. Here we're out. Now we graph. You see discontinuity at x equals 3. But at 0 we see no such thing. And what do we have to do to be able to see it? We'll take the second graph. And at x equals 0, we have an error message. As we do likewise for this. But those would be our discontinuities. At x equals 0 and at x equals 3. So that would make A our correct answer. Number 7. This following functions has real zeros of -1, 1, 3, and 4. Well, what we'd have to do is we have to say, to get our factors, we put x is equal to -1, x is equal to 1, x is equal to 3, and x is equal to 4. And if we get 0 on the right side by adding 1, we're going to get x plus 1 equals 0. Okay, and likewise, for this one here, x equals 1, subtract 1, we get x minus 1, 0. And for x equals 3, if we have to subtract 3, we get x minus 3 is equal to 0. And finally, for this last one, x equals 4, we get x minus 4 is equal to 0. So you're looking for these factors here. And where do you see these factors here? Well, I think I'm seeing them all in answer choice A. Right? Okay. Next 9. That x equals x squared minus 9 g of x, x, 3 find g of x. What we're going to do is take this g of x and plug in, place this x here, and simplify. So f of g of x is equal to, in the place of x squared, we put x plus 3 squared, and what else? Minus 9. And then multiplying this out, we get x squared plus 6x plus 9 minus 9, which equals x squared plus 6x. And 9 minus 9 cancel each other. So the correct answer for this one is C. Next, 10. The table below shows the number of patent applications in certain years starting 1980, which without regression like exponential data. It might help you set year 1980 to 0, usually more easily analyze data. So what I did is I entered the data in the calculator already, and I went to Stat, Edit, and all the points are there. And what we're going to do is graph this, see what it looks like. So I go up to plot 1, and the function of return it on. And then when we graph, I don't see any of the points there. Well, they're outside the scope. If we go to zoom 9, which is zoom stat, we see this kind of looking operation. Let's look at that equation. So we go to graph. So we see something here. Looks, now we had a problem like this already. Looks like a linear might work, but the curve of a quadratic would work better. Definitely not a square root, definitely not a sine, which is up and down. So our best answer is going to be B, quadratic. Next, 11. Function g of x graph below is cubic function. Based on this graph, which following statements is true? What does cubic function looks like? Well, it's going to be something g of x equals something x cubed. Okay, and this tests our understanding of the fundamental theorem of algebra, which is the number of zeros, real and non-real, is equal to the degree of following the function. So definitely that meets the criteria, but to get a real zero, we touch or cross the x-axis. So we do that once, and so it looks like A is probably pretty goofy, our best answer. 1 real zero, 2 non-real zeros. That's what's complete. So go on to number 12. 12 will give it formula. And all we have to do is plug into this formula here. We'll give it F2. So Richter scale measurement is going to be 3.75 plus log A. A is 9. Let's check that out. .75 plus log 90. So 6.75 is what we're looking at. Okay, this will be our first choice B. 13. We have solved the following equation for x. Now, there are a number of ways we can do these things, one of which is we can take these values for x and substitute in and see which one gives us a correct solution here. And we'll try them one at a time, try one in the middle. You can actually go through and do that. You can solve by graphing. If you set f of x, if you solve one side of the equation equal to 0, if you say set one side of the equation equal to 0, and we subtract out this point 0, 1, 2, 1 on both sides, we're going to get 0 equals 1, 21 times 0.1 to the power of 32 over x minus 0.0121, and just solve by graphing through the equations where the x hits or touches the x-axis, across the x-axis. So I guess I'll put the calculator down. So go here, and put in 121 times 0.1 to the power of 32 over x. And then we come out here and subtract out 0.0121. And graph. I need to go to zoom 6. 6. Do you see anything here? Yeah, looks like you look at something along the line here. We can tighten it in a little better. Window. Actually, I'd go here. I'm going to go y minimum negative 0.5, y maximum 0.5. See what happens here. Graph. It looks like we're crossing the x-axis. You go to table view, second graph. Let's see at 8 we have a 0. So 8 is going to be our answer. Can be done without, so take 121 without graphing. That's 0.1 to the power of 32 over x equals 0.0121. And we divide by 0.012. Well, actually, if we divide by 121, it would be a better way to go, right? So what we get is 1.21 times 10 to the negative 2 power over 1.21 times 10 squared, right? 1.21. Decimal place over 1.2. That's going to be 10 to the negative 4th power. So what we have here is 0.01 to the power of 32 over x equals 10 to the negative 4 power. And if we take a log base of 0.1 of 10 to the negative 4th power equals 32 over x. And we could flip this thing upside down or cross multiply it by, so x is equal to 32 over log base 0.1 of 10 to the negative 4th power. So make sure I get this right. 32 over. 32 over log base 0.1. Log base of 0.1. 10 to the negative 4th power. 10 to the power of negative 4. You get 8. Same thing. Then substituting in the case. Guys, that's how many different ways of solving this? 3 different ways. 14 radioactive substance cesium 137 half-life about 30 years, and exact 30 years half the cesium 137 changes a different substance according to the formula over 2 years. In years, the nearest year will it take 100 grams of cesium 137 pK into 20 grams of cesium 137. And you can do the same thing we did earlier in that last problem. You can solve by graphing. We say 0 equals 100 times 0.5 to the power of t over 30 minus 20, and just change that 0 to f of x, see where the thing touches across the x-axis. Or you could divide by 100, so you get 1/5. So 1/5 equals 0.5 to the power of t over 30. Okay, we can say, all right, let's make this base as exponent, base logarithm, so log base 0.5 of 0.5 of 1/5 is going to be equal to t over 30. So therefore, t is going to be equal to 30 times log base 0.5 of 1/5, which I know is 0.2. So 30 times log base 0.5 of 0.2. So 69.66, which is years, closest to answer choice A. Okay, 15. Population growth given by a following formula. In the formula, we have here 1 plus r. In this case, r is equal to 0.075. And so our population is going to be equal to our initial population, which is 4,000. And then we have 1 plus 0.075 to the power of 6 after 6 years. So we need to square a calculator. 4,000 times 1.075 to the power of 6. We get 6173. People, answer choice B. Okay, next, on 16, the pH of solution is given by pH is negative log x, where x has 9.6, with pH solution concentration of 10 negative 4.5. So our pH, according to the formula, must be negative log of, we have 10 to negative 4.5. If you can just put this in a calculator, you can actually see the logs cancel out with negative 4.5. But just to put in the calculator so that you don't know anything, put a negative log. We have, that's going to be 10 to the power of negative 4.5. And we get for this 4.5. 4.5 is our answer. That's choice B. Next, 17, the formula used to calculate sound tenths and decibels is given below. And you have this formula here we've used several times in class. So you have B is going to be 10, and we have log I over I sub 0. Well, the I we're given is 10 to the negative 6th power, and I sub 0 is 10 to the negative 12th power. And what's happening is 10 to the negative 6 divided by 10 to the negative 12, so like you subtract. So it's 10 to the negative 6 minus negative 12. So it's going to be equals 10 log of 10 to the 6th power, which is going to be 10 to the 6th equals 60. That's what, so that's going to be, that's choice A. Next, 18, Newton's law of cooling. There are a lot of ways to do this, one of which is go ahead and solve for a logarithm. We have answer choices available. And I'm just going to say, let's go ahead and do the answer choices and plug them in. And I think the answer choice is going to be, it has to be C. So if we put T sub T, it's 350. It's not. I think it's 100 degrees. So we'll say 100 equals 72 plus T sub 0, which is 350, minus 72, e to the negative k. K is given as 0.05, and answer choice C is 46 minutes. We should get this, it should equal 100 if we put the right side in. So 72 plus 350 minus 72 e to the power of negative 0.05 times 46 Let's get close to 100 for that, which we do, 99.87. So that is our best answer. Yeah, we can solve it by graphing, use a logarithmic solution, take the natural logarithm of both sides. Either way should be easy. Okay, polynomial function 19, polynomial function f of x equals x times 20x minus 5 squared times 20x plus 3 to the third power makes 3 zeros with different multiplicities. So you have x is equal to 0, and that's a multiplicity of 1, because that's x to 1 power. So I'll just put multiplicity is equal to 1. Next we have x minus 5 is equal to 0. So that's going to be x is equal to 5 is our 0, and that's multiplicity is equal to 5, equal to 2. And then we finally have x plus 2 is equal to 0. Subtract 2. So we have x is equal to negative 2. And we have the third power, so its multiplicity is equal to 3. And so 3 is our correct answer. Put 3 anywhere here. And that's what we have. We don't have to put plus when we have a positive number. On the outside here, it's just by default positive. Function g of x equals 2x plus 3, and g of x as an inverse function f of x was f of 9. We're going to find the inverse of function g of x by making it y equals 2x plus 3. We're going to switch x and y, so we change that to x equals 2y plus 3. And now solving for y, subtract 3, so you get 2y is equal to x minus 3. And then divide by 2, we get y is equal to 1/2 x minus 3 over 2. So this is going to be our inverse function f of x. We can call this f of x, right? F of x equals 1/2 x minus 3 halves. And if we substitute in what is f of 9, let's put in 9 for x equals 1/2 of 9 minus 3.3 over 2, which is going to be equal to 9 halves minus I skipped something. Okay. Oops, I did make a mistake on this one. Oops. Our multiplicity is 3, but our value of our 0 is negative 2. So I'll put negative 2, negative 2. Okay, good. That is our answer. 19. Somehow I was going too quickly through this. So negative 2 is our precalculus. Okay, here we are to factor 20. So we have 9 halves minus 3 halves, which is equal to 9 minus 3 is 6. We have 6 halves, which is equal to 3. So 3 is our answer here. Positive 3. I think what happened is I saw the answer and I got mixed up on the last one. So that's what happened. It's careful that should have been. I saw that 3. It's going to be long. Okay. 21. The town of Fairway has a population of 4,500 after the year 2010. Population growth at any rate of 2.2% since 2010. During what year the town's population exceed 5,600 mark? Your answer is divided. Well, there are different ways you can do this one. start out with, we want to know if we exceed 5,600. So we can take, we'll say f of x, or f of t, is equal to our starting number, 4,500 times 1 plus 0.022 to the power of t. And we can put this in our calculator and see when that happens. We can set this equal on the left side to 5,600, solved by graphing. I'm just going to put this in the calculator and see what we get. We have 4,500 times 1.022 to the power of t. This will be f of t. So what does that look like? Let's go to the calculator. Figure this out. So 4,500 times 1.022 to the power of x, and we graph this thing, we don't see a whole lot. We go to table view, and we can just go here and see when we are exceeding. What is it we had to exceed? 5,600. So go here, and we see we almost got to 5,600, but we exceeded it during the following year. So that would be, this first one year 10 would be 2020, this would be 2021. But what I did, since this was so close, I accepted either 2010 plus 10 or 2010 plus 11. So the acceptable answers for this were 2010 plus 10 or 2010 plus 11. And that would be the year 2020 or 2021. Either one of those would be an acceptable. I think as a matter of technicality, 2021 would be a better answer, but since rounding wise 2020 was very, very close, I accepted either one of these as the correct answer. So I'm going to put 2021. And again, 2021 is post 2010 because we were just a few people short. We were 6 people short at the end of 2010. So we needed to get into 2021 so 6 more people could come on. We could have that amount of 5,600. Okay, last one. Johnny has investment account worth $5,000. How much of this account will be worth 6 years later if the account compounds continuously? And continuous compounding is given by this formula. A, the amount equals the principal, times E to the power of RT. And R is going to be 0.09, and T is going to be equal to 6 years, and P is going to be equal to 5,000. So we just put this in a calculator. A equals 5,000 times E to the power of 0.09 times 6. So go in the calculator, get out of here. We have 5,000 times E to the power of 0.09 times 6. We get 8580. And I had some people who put the 0.03. If you put 0.03, that's, I guess, I should give you credit for that, but it really should be, the nearest dollar is 8580. If you put 0.03, I still gave you credit for it, but it really should be 8580. So here we are. I don't know. I saw some people miss this problem. I don't know how it was possible to miss it with the formula in hand. There's some misunderstanding going on. All right. That's it. Good luck. And thanks for viewing.